In the last video, we talked about calculating taxes. In this video and then the next several videos, we're going to talk about calculating interest. So just like most people will be subject to tax during their lives, most people will also be subject to interest. So what is interest? Well, interest is the amount of money that we either receive when we lend or invest money, or it's the amount of money we pay when we borrow money. So think of interest kind of like rent. So if you take out a loan, you're borrowing someone's money. You may not be borrowing property, but you're borrowing something. So interest is going to be the rent, in a sense, that you're charged for borrowing someone's money. If you've ever wondered why they pay you interest on a savings account, so interest can also be an amount of money that you make. If you put money into the bank into a savings account, they may pay you interest. Well, it's just sitting there in the bank, so why are they actually paying you interest? Well, they're actually borrowing your money. So in terms of financing bank operations, making loans to other people, the bank actually uses your money. They actually use your money to lend to other people. It doesn't mean that you don't have your money available. It just means they're using it temporarily in order to finance their operations. So in exchange, they're paying you rent. So anytime we're borrowing someone else's finances or financial resources, we end up paying rent for it, and this is what we call interest. So the amount of interest that we pay is going to be based on principal. Principal is the original starting amount anytime we make a loan. So if we're putting something into the bank, if we're depositing money, principal is going to be the original amount we deposit. Or more commonly, if you're thinking about a loan, principal is going to be the original amount borrowed. So if you're taking out a loan to buy some particular type of item, it's going to be the amount of the loan. It's going to be the amount that you would have otherwise paid out of pocket for the item that instead you're being loaned. We're going to think of that as principal. Think of it as the starting point for your loan. So your loan is going to increase in value over time. The increased amount represents the interest you're being charged. So the principal you have to pay back no matter what. The principal is the actual amount you borrow. But by the time you pay off your loan, typically you're going to end up having paid more than what you would have originally paid out of pocket for whatever you were loaned. So the extra amount that you're paying is what we think of as interest. So interest is typically going to be calculated using a percentage that we call the interest rate. This rate is going to be applied to the principal over a set period of time. Now, most interest rates are considered to be annual. This is going to be important for our purposes because we've got to make sure things are apples to apples. So our interest formula is going to involve the use of a rate, our interest rate, and then also a period of time. Now, what I mean by apples to apples is if we're looking at an annual interest rate, the amount of time is going to have to be in years as well. So if we're given an annual rate, but we're given a time in months, we're actually going to have to do a little bit more work. We're going to have to convert our time period to years so that we have an annual rate and we also have a time that's annual as well. So just keep that in mind. We'll look at a couple examples where we have to deal with that, and hopefully that'll make more sense. So what we're going to talk about in this video specifically is simple interest. Simple interest is one version of calculating interest that applies one particular set of formulas. So simple interest involves interest that's calculated on the principal only. In other words, every time you're charged interest, all they're charging you interest on is the original amount that you either deposited or borrowed if we're thinking about a loan. So anytime you calculate interest, it's only based on what was in the account at the very beginning. It's not based on anything else that's then been added to the account over time. If we base our interest on amounts that have been added to the account over time, then we actually have a different type of interest, which we'll talk about later. So simple interest, we're only calculating interest on the principal. So we have two formulas. The first one we're going to look at is just the formula for calculating interest. In other words, the amount that's owed, the additional amount, the rent that's being charged. How do we calculate that? Well, simple interest is defined as the principal amount in the account times our interest rate times the amount of time. And if we write that in variable form, that's going to be I is equal to PRT. Now don't forget, our percent is going to have to be a decimal first. Our interest rate is expressed as a percentage. We can't use percentages in algebra. We have to use decimals first. So that interest rate will have to be converted anytime we want to do a problem involving interest. And then also this issue with time. Remember, I mentioned a moment ago, it's got to be apples to apples. If our interest rate is annual, then the amount of time has to be in years as well. So if we're talking about days or we're talking about months, something like that, we're going to have to convert that number so that our time is in terms of years instead of it being in terms of months or days or whatever type of unit we have. We'll talk about how we do that in a little bit. So let's look at a couple of basic examples. So for example, you deposit $2,000 in a savings account at a local bank, which currently offers a 6% interest rate. Find the interest at the end of the first year. Okay, what we need to do every time we see a problem like this is identify all the key parts. So what are the key parts here? Look for anything that's numeric and look for anything that's related to time. Okay, so we've got $2,000, that's going to be important. We have 6% as an interest rate, and then we were told end of the first year. So we've got to think about the formula we're going to use. The formula is I is equal to PRT. All four of these variables are represented in any problem. The key is just determining what amounts represent what variables. Well, we have to think about what the different variables represent. So P is our principal. P is the amount in the bank. It's what we put in the bank or it's the loan we take out. R is our interest rate. And then T is the amount of time. So in this case, we've deposited $2,000 in the bank. Because that's our deposit, that's what we're making interest on, $2,000 represents our principal. So that's going to be the amount of principal. Now the interest rate is usually the easiest thing to identify because it's going to have a percent. So 6% is our interest rate. So 6% is going to be our value for R, or rather the decimal version of 6% is going to be our value for R. Now T, we were told we wanted interest at the end of the first year, which means 1 year after we deposited it. It means that the money has been in the bank for 1 year, so we've had 1 year to accumulate interest. So that means T is going to be 1. So I'm going to take all of those values, I'm going to plug them into my formula. Now the question was find the interest. So I is our unknown. We know P, R, and T, and then I is what we're solving for. So I'm going to plug in the values for P, R, and T. $2,000, 6% is 0.06. Let's verify that. So remember, percent just means divide by 100. So 6 divided by 100 comes out to 0.06. So that's going to be the version of our interest rate we're going to use. And then 1 year of time has elapsed, so we're going to multiply by 1 as our value for T. So let's do that in the calculator. So we have 2,000 times 0.06 times 1, and that's going to be 120. Well, 120 what? Well, if we're talking about interest, we're talking about money we have to pay back, it's going to be $120. So for this particular account, at the end of the first year, we have $120 worth of interest in the account. So that's if we're making money. Now, what if we have a loan? So a student took out a simple interest loan for $1,800 for 2 years at a rate of 8% to purchase a used car. What is the total interest on the loan? Now again, we actually have the same parts here. So we know we want to calculate interest, so we're using this formula. We need our principal, we need our rate, and we need the amount of time. Well, the loan was worth $1,800. That was the amount that was borrowed. So the amount that's borrowed is what we define as principal. So principal is going to be $1,800. The interest rate is 8%, so R is going to be 8%, or the decimal version of it, so that would be 0.08. And then it says we're keeping this loan for 2 years, so we're going to pay it back after 2 years. In other words, we want to know what would interest be for 2 years instead of just 1 year like the previous example. So my interest is going to be my principal, $1,800, times my interest rate, which is 0.08, times the length of time, which is going to be 2. So let's calculate that. So 1,800 times 0.08 times 2, which is $288. So if it's $288 for 2 years, how much is it per year? Well, if you were to take that and divide it by 2, that's going to be $144. Now, this is specific to simple interest. The fact that I was able to take the total amount of interest and just divide it up over 2 years, and that gave me the individual amount of interest per year. That does not always happen with interest calculations. That's specific to simple interest. So when we look at more complicated situations involving interest, there will be other situations where the amount of interest from year to year actually changes because we're not using this particular formula, because there's a little bit more going on behind the scenes. But when we're talking about simple interest, we're talking about interest on the principal only, which also means the amount of interest accrued from year to year to year is always going to be the same. So for the first example, we said it was going to be $120 worth of interest at the end of the first year. If we kept the account for another year, we'd get another $120. If we kept the account for another year, it would be another $120, so on and so forth. It's a set amount of interest for every single year, whether we're either loaning the money to someone, in other words, putting the money in the bank, putting it in an investment, or if we're getting the loan and then we're having to pay the interest. It's always going to be a set amount from year to year. So simple interest is often used for short-term loans that will last less than a year. For long-term loans, we typically have another type of interest, which again, we'll talk about later. So in this case, if the loan is for less than a year, T cannot typically be given in years to start with, in which case we have to express time as a fraction of the number of days in the year. Now, when we start talking about this, there's another thing we have to consider called the banker's rule. So the banker's rule is going to allow the bank to simplify interest calculations by taking 365 days and making it 360 instead. It just makes the calculations a little bit simpler. So say, for instance, you had a loan for 90 days. Well, the fraction of the year would be 90 days out of the total number of days in the year, which would then be 365. Well, 90 out of 365 doesn't actually divide evenly. The numbers end up looking really, really nasty. Whereas 90 out of 360 actually reduces really nicely. So this rule is just going to allow the bank to round off 365 to 360 to simplify their calculations. The bad news is ultimately that benefits the bank. It doesn't benefit the consumer. It typically means you're charged a little bit more interest than you would be charged if we were thinking of taking the year out of 365 days. But in most cases, that change is going to be pretty much negligible. So again, if we're thinking of something as being part of a year, months out of the year, or just days out of the year, time is going to be a fraction. So it's going to be the part of the year out of the whole involved for the total length of the year. So let's look at another thing with relation to interest, and then we'll revisit this idea of short-term loans, what we call the future value. So what we just calculated is interest. In other words, what's owed on the account, what do we actually have to pay in terms of rent? Well, we're not paying just the rent though. We have to pay everything. So not only do we have to pay the rent on the money, but we have to pay back the money that we rented, right? Because it's not ours. We were loaned that money. When we pay the loan, we have to pay back both the principal and any interest accrued. So let's think about the second example we looked at. How much will the student who borrowed $1,800 for 2 years at 8% interest have to repay? In other words, this particular one. So we determined the loan was going to be worth $288 worth of interest. Okay, so that's how much interest is owed. But when this student pays it back, how much will this person owe? Well, they have to pay back the $1,800 because that was borrowed. But remember, they were charged rent. They were charged $288 worth of rent, which we call interest. So the total amount of repayment is actually going to be the sum of those values, which comes out to $2,088. So not only are they paying back what they borrowed, but they're also paying the interest, which means they have to pay more than what the loan was originally worth. This is what the loan is worth at the beginning. This is what the loan is worth when it has to be repaid. So we have specific names for these values. The amount due is what we call the future value of the loan. It's what the loan is going to be worth in the future once it accrues interest. What it's worth at the beginning, in other words, think of that as today. If you took the loan out today, it's what it's worth today. We call that the present value. It's what it's presently worth. Well, how do we actually calculate what the account is going to be worth? We can do what we did here, which was a two-step calculation. We calculated how much interest would be owed, and then we summed up the borrowed amount with the interest, and that told us in total what we were going to owe. There's another way to do this. So our account balance, A stands for account balance, the future value, it's what we're going to owe. The account balance is going to be the principal, what we borrowed, plus what we're being charged in interest. Another way of representing this, and the formula that we're going to use, is going to be P, which again is our principal, times the quantity, 1 plus RT. So R and T still represent the same things. Think of 1 as representing 100% in a sense. So we're paying back 100% of the principal, and then P and R and T represents our interest. So it ends up being the same thing, just in a slightly different form that keeps us from having to memorize two different formulas and use two different formulas at the same time. So that's going to be our formula if instead of calculating interest, we want to know what do we owe in total? What is the actual future value of the account? So let's do a couple examples. A loan of $1,060 is made at 6.5% for 3 months. Find the loan's future value. Okay, so it says find the future value, not the interest. In other words, what we want to know is what is the loan going to be worth in total once we have to pay it back. Not just what are we going to owe in addition to the borrowed money, but what's it going to be worth in total. Okay, so that tells me I'm going to use the formula that has A in it. A stands for account balance. Think of that as future value. Okay, so what do we know? Well, the loan was made for $1,060. So that's going to be the principal. That's the original amount of the loan. 6.5% is our interest rate. And then we have this loan for 3 months. Notice it's not 3 years, it's 3 months. So when we're looking for the value of T, T is not going to be 3. 3 would represent 3 years. It's implied that our interest rate is annual. If we're not told otherwise, we assume that the interest rate is annual. But if we were to put 3 here in place of T, that implies that we're saying 3 years, when we actually mean 3 months. So what we have to do is we have to take this particular value, which is a part of a year, and convert it to years. In other words, we have to write what fraction of the year that represents. Well, how do we do this? Well, think of it as a part to a whole. So we're talking about months. 3 months is a part of the year. Well, if we're talking about months, then what would the whole look like for the year? In other words, how many months are there in the year? Well, a year has 12 months. So the part is 3 to a whole of 12. 12 months represents the whole year. So the fraction representative of time in this case is going to be 3 out of 12, since it's 3 months out of a total of 12 months. So in place of T, I'm going to use 3 out of 12 as opposed to 3. So I'm going to plug into my formula. So my account balance is going to be my principal, which is $1,060, times the quantity, 1 plus my interest rate, 6.5%. Remember, we convert that to a decimal, so 6.5 divided by 100 is going to be 0.065. I highly recommend, don't try to guess on converting your percents to a decimal. Do it in the calculator just to be safe. If you leave off a 0 or if you add an extra 0, it changes the problem a lot. So don't let that be the point where you make a mistake. So that's going to be our interest rate. And then again, time is going to be part to whole, so 3 months to 12 months. Okay, so let's simplify all of that down. Now you can do this actually in one line in your calculator. So I'm going to show you how to do this in 2 different ways. What if you want to do this in one line? Well, this particular calculator is really great just because of the fraction. The fraction is sometimes a problem. we actually have a button to represent fractions on this calculator. So this calculator lets us do fractions pretty easily. So I'm just going to type this in as written all the way across, keeping in mind that those parentheses are important. So we have 1060 times 1 plus 0.065 times the fraction 3 out of 12. So for the fraction, when you want to enter in parts, you use the arrows to tab over and to go to a different part. And then I'm going to tab over out of the fraction. I'm going to close my parentheses. Now, if I want to review this before I press enter, I can use the arrows and I can go all the way back to the very beginning. And I want to double check that I typed exactly what I wanted because there's a lot going on here. So we have 1060 times 1 plus our interest rate 0.065 times our fraction of a year, 3 out of 12. And that's exactly what we want. So now I'm going to hit enter. And there we go. That's going to give me my future value. We're talking about money. So either we'll round to the whole dollar or we'll round to 2 decimal places for cents. So if we round to decimals, that's going to be $1,077.23. Okay. Now, what's another approach? What's the drawback to doing this, for instance? Well, suppose you're taking a test and you're attempting to show your work. If you type all of this in, but say you type something wrong, well, we know the final answer is going to be wrong, right? Well, the problem with typing all of this in is if you make a mistake, it's going to be next to impossible for anyone to see where your mistake was. So the likelihood of you getting partial credit for something like that decreases because you can't actually see your work. That doesn't allow you to show any work on the paper. So I want to talk about an alternative way that you could type all of this in. So I'm going to clear this out. Okay. I want to go through all of this, through this whole expression that I typed in one line in a calculator, and I want to analyze what's really going on, specifically in terms of order of operations. In other words, think about what's here. I have a multiplication, I have an addition, I have a multiplication, I have a division. I've got a lot of stuff going on, right? Okay. What if I were to just go one operation at a time following order of operations? What would I have to do, and in what order would I have to do it? Well, we know that order of operations always starts inside parentheses. So the first thing I would have to simplify would be inside the parentheses. Okay, well, there's also a couple things inside parentheses. There's an addition, there's a multiplication, there's a division. So I actually have 3 different operations represented in the set of parentheses. So where do I start there? Well, multiplication and division always come before addition, so I'd start in there. Notice I'm multiplying by a division problem. So in order to do the multiplication, I need to know what was divided first. So the actual first step I would need, if I'm going to go one step at a time, is going to be the division. I need to do that first. So if I'm going to go step by step, I'm going to start by doing the division. So I'm going to do 3 divided by 12. A fraction and a division are the same thing. So keep in mind 3 out of 12 is also 3 divided by 12. They mean the same thing. Okay, so the result of that one division is 0.25. How does it help me to do it this way? Well, if I wanted to show my work step by step, I can then replace the 3 out of 12 with a 0.25, and I've shown my work. What I can also do is I can then build on this in the calculator. So as opposed to having to literally write it down and type in everything again every single time, I'm just going to add on an operation each time I have a subtotal in the calculator. So where would I go from here? Well, I just did the division. What would the next step be in order of operations? Well, I need to multiply. So I would need to take the result of that division and multiply by 0.065. So if I immediately hit multiply and then just type what I want to multiply by, notice it just pulls in the answer from the previous line and it does the multiplication we want. It builds on the most recent total. So you can take one operation at a time and then you can build on it, and by the time you've done all the operations, you'll be down to your final answer. So I'm going to do that multiplication building on that division. Okay, so that's now division number 1 and then multiplication number 2. Well, the last thing we'd have to do in parentheses is add the 1, so plus 1, and there we go. That's everything in parentheses. So I have that simplified down. And again, the benefit of this means that I can write that down. So if I were to make a mistake maybe up to that point, but the rest of the problem looked good, I'm more likely to get partial credit for something like that than just doing it all in the calculator and maybe I get it right, maybe I don't get it right. It's kind of just luck at that point. So I'm going to build off this again. What's the last thing I have to do? Well, I did everything in parentheses. So the last thing I need to do is multiply by that number out front. So times 1060. And notice I get the same answer, no different. It's the same answer if you go step by step as if you type it all the way in. So there are benefits, there are drawbacks to doing it either way. This certainly takes a little bit longer, but again, it's going to allow you to show your work step by step, and there's always benefit to being able to do that. I also want to show you this because as we go to additional sections and we talk about slightly more complicated situations, we're going to run into some formulas where it's going to be hard to type it all in one line. It's going to be difficult to do it just typing it all in from start to finish. So being able to do this in your calculator and build operation on top of operation is going to be a valuable skill to have. So sometimes I'll type it all in straight across, sometimes I'll build on it. It's just going to depend on the situation. I would encourage you to try it both ways and make sure you're flexible enough to do it both ways so that you can adjust when the situation requires that. Okay, now let's look at another one. So a loan of $2,040 is made at 7.5% for 4 months. Find the loan's future value. Okay, in other words, what are we going to have to pay off $2,040 as a loan, considering that it accrues interest this way and for this length of time? So again, we're going to use our formula for A. Our principal is $2,040. Our interest rate is 7.5. So 7.5 divided by 100 is going to be 0.075. So that's going to be our value for R. And then it's 4 months out of the year. So again, we're not going to put 4. 4 as a value for T would mean 4 years, but we mean 4 months. So 4 months is the part of the year. So the part would be 4. The whole would be 12. So 4 out of 12 is going to be the length of time. So let's just type this all in straight across. Again, this one's not too bad to type in straight across as long as you're careful and you just check yourself as you go. So 2040 times 1 plus, and that's not what I want, plus 0.075 times the fraction 4 out of 12. Close my parentheses. And there we go, 2091. Okay, so that's going to be our future value. That's the check you would have to rewrite. Well, what if you then were asked the question, how much of this is interest? So find the loan's future value. How much of this is interest? Well, think about what interest means. Interest is the rent you're being charged. What does this payment represent? So say you write a check for $2,091 and then you submit it in order to pay off your loan. What does it represent? Well, it represents the original $2,040 you paid off, but notice it's more than that. The excess represents interest. So if you want to know how much of that repayment is going to be interest, it's always going to be the difference between your principal, what you actually borrowed, and what you actually have to pay in order to pay off the loan. So if we were to subtract the principal from that, that tells us how much of that repayment is interest. In this case, $51 of that repayment check represents interest. So there are different ways to use these formulas to answer different kinds of questions. What we're going to look at now is how we can answer questions about different variables in the formulas. So notice this particular formula actually has 4 variables. We have A, P, R, and T. Remember, this is a 1. This is not a variable, it's just a 1. But we have 4 variables. Ultimately, we can solve for any one of these variables as long as we know the other 3. So that's what we're going to do. Different situations, we may have different information, but by substituting what we do know, as long as we can replace 3 variables out of the 4, then we can solve for an unknown value. So for the 2 we've already done, we just substituted for all the variables in the actual formula, and the answer resulted in A, our future value. Well, what if we know the future value, and maybe we want to solve for one of the other values? we can do that as well. It's going to require us to do a little bit more algebra and work a little bit backwards, but as long as we know 3 out of the 4 variable values, then we can solve for any unknown we want. So let's do a few examples doing that. Now, it's going to be more important than ever that you're able to identify what the different variables represent, what the different values in your problem represent as being assigned to variables. So that's always going to be the starting point. The hardest one to identify is going to be principal versus future value. So I'll show you sort of a trick for representing that, for making sure you can determine which one is which. Okay, so you borrowed $2,500 from a friend and you promised to pay back $2,655 in 6 months. What simple interest rate are you paying? Okay, well, let's look at the question first. The question is, what simple interest rate are you paying? So that means in this case, our unknown is R. We don't know the interest rate. And if you scan through the whole problem, there's no percentage anywhere. So R is our unknown. Well, if R is our unknown, that means all the other values have to be given in order for us to solve for that value. So we need to be able to have A, we need to have P, and we need to have T in order to leave R unknown and be able to solve for it. So we're looking for A, P, and T. Well, T is going to be the easy one to spot. It's the only thing related to time. So we're talking about 6 months. So that means T is going to be 6 out of 12. It's not 6, but it's going to be 6 out of 12, so half of the year. Now A and P is where it's a little harder, because notice they're both going to be dollar amounts, but which one is which? Well, think about what represents where the account starts and where the account ends. Another way to think of it is principal is always going to be less than your account balance. It's always going to be smaller. But the amount you borrow is your principal. The amount you repay, or the amount that the loan is worth in the future, is your account balance. So that's going to help you make that determination. So you borrow $2,500 and you promise to pay back $2,655. Well, this is the amount you borrow. The amount you borrow is defined as your principal. So that means principal is going to be $2,500. You're paying back $2,655 in the future, sometime in the future. So because you're paying this value in the future, it represents your future value. So that's going to be A. So what we're going to do is we're going to take that formula for future value and we're going to replace everything we know. We know A, we know P, we know T. We're going to replace everything in the formula with what we know, and we're going to leave R as our variable since it's our unknown. So A is 2,655, P is 2,500. We have 1 plus R times T, and then our T is 6 out of 12. Now this is not as simple as just type it into your calculator and go from there. We're going to have to work with this one kind of the way we worked with the one where I typed it in one operation at a time. The goal is to isolate R. Once we have R by itself, all of the algebra we've done to isolate it is then going to have R equal to whatever answer we want for this particular problem. So we have to peel off layers in order to isolate our value for R. So where do we even start? Well, I'll give you a strategy for that in just a second. First thing I would do, I would go ahead and take that fraction and rewrite it as a decimal, just so it's going to be easier to work with. So take 6 divided by 12 and you get 0.5. So I just rewrote things in parentheses a little bit differently. 1 is still 1, but I have R times 0.5. A cleaner way to write that is just 0.5R. It means the same thing, just a little bit cleaner. So here's where I currently stand. I didn't really change anything, I just rewrote things in a slightly different way. But I haven't actually done any algebra to speak of. So my goal is to isolate R. I want to peel off all the other layers in order to get R by itself. Well, how many other layers are there? Well, there's the 0.5, there's the 1, and there's also the 2,500. I have to find a sequence of algebraic steps that's going to allow me to eliminate those 3 parts and keep the R by itself. Well, how do I know what I need to get rid of and what order I need to do it in and how I need to do it? I want to go back to order of operations. So forget about the left-hand side for a minute. We're just going to look at the right-hand side of this equation that we're trying to move things around, isolate the R. I want you to think about all the steps that are associated with the right-hand side of this equation. What all is here? Well, we have a 2500 that's multiplied. We have a 1 that's being added. We have a 0.5 that's being multiplied. Now, if we were to follow order of operations, suppose there was a value in place of R. Say there was a 1, a 0, anything you want, doesn't matter. But say there was a value in place of it, and you wanted to take this whole right-hand side of the equation and you wanted to simplify it based on there being a number there. What would you do, and what order would you do it in? Well, order of operations says you'd start in parentheses, so you'd have to start simplifying inside. So you have an addition, you have a multiplication. Well, if we have a number right here in place of R, the first thing we would do is we would multiply those two numbers together. So the first step in simplifying would be the multiplication. Okay, now we've multiplied. So what would the next step be? Well, the next step, the second step, would be to add the 1 onto that. So multiply for the first step, and then add the 1 for the second step. That would then reduce everything in parentheses to one number. So what would the final thing be that you'd have to do? Well, you'd have to take the result of that and multiply it by 2500. So that would be the third step you would do. So multiply 0.5, add 1, and then multiply by the number on the outside, 2500. Okay. That's if we had a number in place of R and we wanted to simplify everything down and just get an answer. Okay, that's not quite what we want to do here though, because remember R is unknown. So if that's not what we want to do, then why did I just walk us through that? Well, here's the shortcut, here's the trick. It's not really a trick, it's just this is the technique you can follow. We're going to do order of operations, but we're going to do it backwards. So this was our first step. This was our second step. This was our third step. We want to undo all these things. Isolating a variable means undoing all these things, undoing the multiplication, undoing the addition, undoing this multiplication. But we have to undo them in a specific order. It's always going to be the opposite order from the order we would simplify if we were following order of operations. So this would be the first thing to simplify, then the second, then the third. If we're going to isolate the R, we're going to do all the opposite things, but we're going to do them backwards in the opposite order. Well, what does that mean for practical purposes? Well, this was the first thing, this was the second, this was the third. So if we're working backwards, the first thing we'll have to get rid of is the 2500. That's going to be where we start. That was the last step in order of operations, so it'll be the first step if we work backwards. So it's 2500 and it's being multiplied. The operation between the 2500 and the rest of that particular expression is going to be multiplication. Well, how do you undo a multiplication? You divide. So we would have to take both sides of the equation and divide by 2500, which would move it over and it would get rid of this 2500 on the right-hand side. So I would be taking 2655 and dividing by 2500. So 2655 divided by 2500. And we're going to have to do this step by step. This is not a build on it in your calculator. We're going to do it step by step and write down things as we go. So if I divide out that 2500 and move it over, I have 1.062 on the left-hand side. And now I'm just left with whatever was in parentheses. Okay, so if we go back to order of operations, again, this was the last thing to simplify. This was the next to last thing, which means it's now the next thing that has to move. It's a 1, it's a positive 1, and notice that it's added. So in order to get rid of a positive 1, I have to subtract it from both sides. So based on what I currently have on the left-hand side, I'm now going to subtract that 1, which eliminates it on the right and moves it over to the left. So minus 1 gives me 0.062. And now all I have left is the 0.5 times R. So 0.5 is multiplied by R. In order to get rid of it, I have to divide it. So I'm going to divide 0.5, and that's going to give me my answer. So divide, and we get 0.124. Now that's the answer, but we're not quite there, because what was the question? The question was, what simple interest rate are you paying? In other words, we want a percent. Well, this is the decimal version of the percent. How do we get the decimal version? Well, we take a percent and we divide by 100. So if we want to go backwards to take the decimal to a percent, we would then multiply by 100. So if you take this number and multiply it by 100, that's going to give you the percent version, which in this case is going to be 12.4%. So that is going to be our interest rate. Now let's do another one like this, solving for the same kind of thing, different numbers. Again, try to build on it in your calculator. If you want, maybe pause the video and see if you can try the next one on your own, and then we'll go through it together. Okay, so to borrow money, you pawn your guitar. Based on the value of the guitar, the pawnbroker loans you $960, so that's the amount of the loan. 1 month later, you get the guitar back by paying the pawnbroker $1,472, so that's your repayment check. What annual interest rate did you pay? So same question as before, we're looking for the interest rate, which automatically means the other values, the other variables have to be assigned a value. So time is 1 month later. Okay, so we pawn the guitar and then 1 month later we're gonna go get it. So time is gonna be 1, but not just 1 month out of 12 months. So time is 1 out of 12. Okay. Principal is $960. Why is that the principal? Well, that's the amount you're loaned when you make the loan, or when you pawn your guitar. That's the amount you're given. So that's going to be the principal. That's the value that the account starts at. And then 1 month later, this is the amount you have to repay. You have to pay back $1,472. So that is your future value. That's the account balance. So that's going to replace A. So physically, we have the same setup as before. No different, no change. Same setup. Okay, so I want to start the same place I did before. Let's go ahead and take that fraction and convert it to a decimal, just to make it a little bit easier to work with. So I'm going to take 1 and I'm going to divide it by 12. And notice it's a repeating decimal. Sometimes you can build off of a repeating decimal in your calculator, or sometimes you can't. In this case, it's not going to be that easy to do. So I'm going to approximate that. Now, how do you know how many decimal places to round to? Well, think of where you're going to be in the end. We're looking for an interest rate, and let's say we want maybe 1 decimal point for an interest rate. Try to keep as many decimal places as you can, but you need at least 1 or 2 more decimal places than you plan to round to at the very end. So say you plan to round to 1 decimal place at the end. Well, ideally keep at least 2 or 3 while you're working, and then it's less likely that rounding is going to be an issue at the very end. In this case, I've kept 4, just because why not? It doesn't take any longer to write 4 than it does to write 3, realistically speaking. So keep as much as you can. So I'm going to write down the value of that fraction converted to a decimal. Now again, I want to isolate my R. I want to get rid of everything that's then on the same side of the equation as R by working backwards. So if I had a value for R and I was going to follow order of operations and simplify everything on the right hand side, I'd do the multiplication, then the addition, and then the multiplication with the number on the outside. That means I need to work backwards to peel off the layers and isolate the R. So if the last step would be multiplying by 960, then when I solve for R, the first step is dividing it, is getting rid of it, is taking it out and putting it on the other side of the equation. So I'm going to start by taking 1472 and dividing it by 960. And again, I get a repeating decimal. And again, I'm just going to round to maybe 4 places. That should be enough. So the result of that division, well, the 960 is reduced on the right-hand side. And then on the left-hand side, we have about 1.5333. Okay, so then on the right-hand side, we've eliminated the 960. Now we're just left with everything that was in parentheses. Again, go back to order of operations. I would multiply and then add. So I have to work backwards to solve. I have a positive 1. So in order to get rid of it, it's a positive 1 that's added. I'm going to subtract it to move it over. So I'm going to take the result and I'm going to subtract it. I'm going to subtract a 1. Or let's build off the rounded version. So 1.5333. minus 1. And I get 0.5333. Okay, now what's left is r and its coefficient. So I'm going to divide out that number in front of r from both sides. So divide 0.0833. And that is going to give us our answer. Now, be careful in interpreting this. This is not a percentage. This is a decimal. We haven't done anything to convert it. This is basically the same thing as 0.124. It just so happens that we don't have a 0 in front of the decimal place. So what does this really mean? Well, we need to convert it back to a percentage, so we're going to multiply by 100. We would divide by 100 to go from percent to decimal. So to reverse it, we multiply by 100. And that's going to give us our percent. That seems kind of mind-blowing, 640% roughly. Why does that actually make sense in the context of the problem though? Well, that's 640% per year. What that really means is take the original amount and you're going to have to pay 6.4 times that in interest. So you would pay 960 6.4 times over just in terms of interest. Now we're only paying 1 month's worth of interest though. But why did this actually make sense? Well, think about how much more you had to pay. You started with something that was supposedly worth $960, and when you paid it back, you paid almost $1,500. That was almost time and a half what you had to actually get for the loan originally. So it makes sense that we have a really high interest rate. Just because it went up so much over 1 month, it makes sense that there's a very high interest rate. So even though it might seem strange to see something like 640%, in a situation like this, just because the value grew over only 1 month, not even a whole year, just 1/12 of a year, because it grew so much, that it means the interest rate is actually a really high interest rate. So that's what it's going to look like if we want to solve for r. Now keep in mind, if you wanted to solve for t, exact same thing. Structurally speaking, it would be the same thing. You would just have a value for r and t would be your variable. But in terms of the algebra, it would look the same. You wouldn't have to do anything different for either of these two if the goal was to solve for t instead of solving for r. Let's solve for another variable though. So here's another question. What amount of money can you invest for 300 days at 5.5% simple interest to earn $93.80? And we've been told to use 365 days for a year. Okay, what's the question here? The question is, what amount of money can you invest? In other words, what can you deposit in an account? What can you put in the bank today in order to meet a goal? Well, if we're describing an amount we're putting in the account today, then we're describing principal. So the unknown in this particular situation is actually principal. That's going to be our variable. Well, that means that more than likely we should have the future value somewhere. Well, here's our other value, our other monetary value we were given. We have to be careful though. We didn't say that this is how much the account is worth. Notice what it said is that it's going to earn this amount. This is the amount that's going to be added to the account. It's not going to be the total value of the account. This is the amount that our account is earning. Well, if we're talking about an amount that our account is earning, that's what we mean by interest. So this is not actually A, this is actually I. This is actually the value for the interest. Well, if P is our unknown and we've been given I, what do? Well, all we have to do is use a different formula other than the A formula. Use the formula that involves the variables we know. So we were given I and we want to determine P. That just means we're going to use the formula for interest rather than the formula for future value. So take a look at every problem. Start by identifying what you do and don't know. Based on what you do and don't know, that's going to tell you what formula you have to use. So because in this case we were given a value for interest and not the actual future value of the account, we can just use this formula instead, and that will allow us to take care of everything we do and don't know in this problem. So that's going to be I, and then P is going to be our unknown. Well, if we're going to use the formula with I, we need to have R and T. So R is 5.5%, or 0.055. T is going to be 300 days. Now again, that's a part of a year, and we've been told to use 365 days for a year. So the part to the whole is going to be 300 out of 365. So we're going to let that be our value for T. So plugging into the formula, interest is 93.8, and its interest is equal to principal times rate times time. Principal is our unknown. Our rate is 0.055. and the amount of time is 300 divided by 365. Okay, so what all do I have going on here? Well, I need to isolate my P. P is multiplied by a couple of numbers. So I could take a couple different approaches here. I could divide these out one at a time if I want, or maybe a better way to do it is just go ahead and do the multiplication here. This is a division, this is a multiplication. Notice these are constant fixed numbers. I can go ahead and simplify all of the other numbers on the right-hand side of the equation other than our variable, and that will simplify things quite a bit. So I'm going to start by just taking care of all of this and rewriting that as one number, since it's just a division and then a multiplication. So I'm going to start with the division. It's multiplied by a fraction, so the fraction needs to be taken care of first. So 300 divided by 365, okay? We might round that, or we can just build on it. So just directly multiply that by 0.055. Okay, and that tells us what is multiplied by P. That's the number multiplied by P. So I'm going to round to 4 decimal places, so 0.0452. Okay, so what are we doing with that number? Well, that's being multiplied by P. So if the goal is to isolate P, we have to undo this multiplication in order to get P by itself. So I'm going to divide both sides by this number that's multiplied by P. Now I want to show you something you can do in a calculator that will help you get more accurate answers. Here's one thing you can do. If we were going to just type in the division, we type 93.80 and then we divide by 0.0452, which is perfectly fine. That's not a problem. What if we had something that we didn't want to round? What if we want to use the non-rounded version in the calculator instead of using the rounded version? Well, do we have to retype everything that's in the calculator? Fortunately, the answer is no. Now here's the problem. Normally we would just build, because notice we did the division and then we just built off of it with the multiplication and I didn't have to retype anything. Why can't I just do that here? Well, the reason I can't do that here is because I'm not building off of this number. I'm taking another number and then dividing by that. So I can't just type divide and 9380 because that's not actually the correct order for division. Division is not commutative. Order matters. But what I can do, here's what I'm going to do. I want to do 9380 divided by this number, or technically divided by this number. So here's what I'm going to do. I'm going to do 9380, type that in. I'm dividing, and then I want to divide by this particular number. Here's the rounded version. I want to divide by the whole version though. Here's what I can do rather than retyping all of this. If you look at the very bottom of your calculator, right above the negative button in green, it says ANS. ANS stands for answer. It means the answer from the previous line. So anytime you want to copy and paste an answer from a previous line, if you use this button, but notice it's in green, what does the green mean? The green means you pressed second and then that button. So if you press second and then that button, that pulls up that answer from the previous line for you. It copies and pastes. What it really does is it copies and pastes all the algebra. So technically speaking, this is actually just a rounded version of what we got. All of these are rounded versions based on how much your calculator can display. But by putting this in, the calculator has saved all of the algebra that's really in the background, not just these values, but the actual algebra behind the scenes. So what your calculator is doing is it's actually copying and pasting all the algebra associated with these values into that line so that you're not really rounding at all. You did this part without rounding, you multiplied and you didn't round. Now you're just taking 9380 and you want to multiply or divide by a version of this number that's not rounded. So by using that second and negative, the ANS operation, you're not rounding anything. You're just building on the answer in your calculator with no rounding involved. So that's going to be a way to get around the issues with rounding. That's going to be important, particularly as we get into more complicated situations with more complicated numbers. Being able to do this is going to be very important. So practice doing this kind of thing. Make sure you try to do a problem like this without having to use the rounded versions. Maybe write down the rounded versions for the sake of showing your work, but make sure you can do it in the calculator with no rounding involved. So we're dividing by the answer. I'm going to hit enter. And then there we go. So $2,074, and then if we were going to round to cents, that's going to be 97 cents. Now, why does the answer I have here differ? Well, this answer is based on the rounded version. So if you were to take 9380 divided by 0.0452, that's what you would get. Which one is right? Well, technically, the first one is the most correct answer. The second one is not necessarily a majorly incorrect answer, but in terms of the most correct, the most accurate answer, it's going to be the first one, because the first one didn't involve any rounding until we got down to the very end. So the less rounding you can do while you work through something algebraically, the better. Particularly if you round in the middle of a problem, that rounding has a trickle-down effect and it affects the rest of the problem. So finding ways to avoid rounding using that A&S operation in your calculator is going to make your life a lot easier. If you type in something to the homework system and it counts it wrong, but you're very confident you did it right, well, odds are it was a rounding thing. So if you rounded somewhere in the middle of the problem and you didn't just build off of the answer in your calculator, that may be why it's counting your answers wrong, even though conceptually you're doing the problem right. So just keep that kind of thing in mind. Let's try another one like that, and we'll go through the calculator work again. So you plan to save $2,000 for a trip to Europe in 2 years. You decide to purchase a certificate of deposit, otherwise called a CD, from your local bank that pays a simple interest rate of 4%. How much must you put in this CD now in order to have the $2,000 you need in 2 years? In other words, you want to meet a goal. The goal is to have $2,000 at the end of 2 years based on an account that pays 4% interest. So we want to have a total of $2,000 to withdraw. So that's the future value of the account that we want to have. Because that's the value we want to have in the future, that's what we're going to call A. So that's going to replace the variable A. Now we have an interest rate of 4%, and we know we want to keep the account for 2 years. So T is going to be 2. R is going to be 4%, or 0.04. And then in this case, we're not talking about interest, we're talking about future value. So A is going to be 2,000. So we're going to use the other financial formula. We're going to use the one that has A, not the one that has I. So we have $2,000 for A is equal to P, which is our unknown. The question is, how much must you put in the CD now, today? What deposit do you have to make? What starting value does your account have to have in order to grow to $2,000? So P is our unknown. And then we have 1 plus our interest rate, 0.04, times our value for T, which is going to be 2. Now, similarly to the one above, notice what's on the right-hand side with our value for P. It's a bunch of constants that are just added and multiplied. That's then one big number multiplied by P. So I could remove each of these individual things one at a time to isolate P, or I can just simplify all of this that simplifies and then just move it over in one step. So that's going to be more beneficial in this case. So I want to simplify everything in parentheses. Now there's no reason not to do that in one step. So 1 plus 0.04 times 2. Your calculator knows to do the multiplication first and then the addition. So it follows order of operations. And that's going to give us 1.08. So that's now the number that's multiplied by P. Well, we want to isolate the P, so we have to get rid of the multiplication. In other words, we have to divide. So I'm going to take 2,000 and I'm dividing by 1.08. Now there's no reason I can't just type in 1.08, but suppose it weren't something as simple as that. Suppose it were a long number that just was kind of a nasty number. How do you take care of that? Well, remember, we can copy and paste it from the previous line. So second and negative, brings up the answer from the previous line. Now again, you cannot start here and hit divide 2000. That's 1.08 divided by 2000, not 2000 divided by 1.08, which is what we want. The order is important here. So I can do 2000 divided by this answer, and then it's going to give me what I want. So in this case, $1,851.85. Now just a word of caution here, for these kinds of problems where you're meeting a goal, you're trying to find some value in order to meet a goal, your directions may say to round up. So even though if we're rounding to 2 decimal places, that 1 tells us to leave the 5 alone, not to round it up, your directions may say to round up. Why would it say something like round up if normal rounding directions tell you to just leave it alone or round down, something like that? The reason it might tell you to round up is because when you're meeting a goal, you have to consider that this is not the exact answer, this is. This would be the exact answer that would help you meet your goal of getting $2,000 in 2 years. But this number is slightly less than this. So if this were the actual number you started with in your account, and then you kept this account for 2 years, you would probably end up with right under $2,000, just because this is a little bit less than the actual answer to the problem. So by rounding up, even though the normal rounding directions tell you to leave it alone and just put it at 0.85, by rounding up, you make sure you meet your goal. So this might leave you a little bit under your goal. If you were to round 0.85 to 0.86 instead, then you'll pass your goal a little bit, but at least you'll meet it. So surpassing it is better than falling short of it. So just keep that in mind. Biggest takeaway there is make sure you read the rounding directions very specifically. If it says round to the nearest dollar, round to the nearest dollar. If it says round to cents, round to cents. If it says round up to the nearest dollar, something like that, make sure you pay very close attention to those rounding instructions. So that's a few examples of situations involving simple interest, solving for our different variables. Simple interest only applies in some situations, and I wouldn't even say it's the most common way of calculating interest. So what we'll talk about next is how we calculate interest in different situations, specifically when we're not using simple interest.